Hi students, today we are continuing with the same problem. Prove that the parallelogram circumscribing a circle is rhombus. So parallelogram is circumscribing. So the parallelogram is the boundary and inside there is a circle, and we have to say that the parallelogram is a rhombus. Rhombus means just we have to say all the sides are equal. So let me draw the figure. So here I have drawn a parallelogram circumscribing. So inscribed the circle here. So here we have to prove about this outer sides are equal. Let me name it as an A, B, C, D, and this point of contact as a P, Q, R, S. So it's like a B, C, D are like a point from the outside, and it has an equal tangent. So and from here we can draw a radius also, right? So to our goal is we have to prove this all the sides are equal, and we know this is 90 degree and this is 90 degree, and so we have to prove that all the sides are equal. That's this AB is equal to BC is equal to CD is equal to DA. So for this, let me prove these two sides are, we already know that these two sides are equal, right? If we prove this and this sides are equal, then this two sides will be equal, right? Already we know this AP is equal to AS, and if we prove that this AP. Hi students, today we are going to continue with the problems. So prove that parallelogram circumscribing a circle is rhombus. So here is a parallelogram circumscribing, and we have to say it is a rhombus. So rhombus means we have to prove that AB is equal to BC is equal to CD is equal to AD, right? And we already know that just I have connected this the center to the point of contact. This is 90 degree forms, and we know that this angle, this side and this side is equal. So if we prove this side and this sides are equal, then this the whole side AD will be equal to AB, right? So let me draw if I draw a diagonal here, then here the two triangles, if we prove the similar, then we can say that so congruence. If we say the congruence, sure we can say the sides will be equal, right? So the same way, by the same way we can prove for other thing also, right? So let me write the parallelogram. ABCD is sub parallelogram ABCD circumscribed a circle with center O. Since it is not given in the question, the figure we have drawn ourselves, so we are naming it, and we know that OP is perpendicular to AB, and also O is perpendicular to AD. We no need to prove all the sides. If we prove one any one, then we can say other by similar. So we are going to compare this triangle OPB and OST. So we have to say that these both are equal. So we have to prove that both the triangles are congruent. So triangle OPB and in triangle OST. So what are the ways we can prove that a triangle is congruent? So one, we know these both are perpendicular. So these two are perpendicular. So angle OPB is equal to angle OSD is equal to 90 degree by theorem 10.1. Clear? So next, the OP and OS are radius, right? So OP is equal to OS since it is a radius. So what is another one? OB and OD is equal since it is a parallelogram diagonal which is bisects. So OB is equal to OD. This is a diagonal of parallelogram bisect. Bisects means it's cut equally, right? So by the two sides and one angle, we can say it's a congruent, right? So therefore triangle OPB is congruent to triangle OSD. If we prove the congruent, then only we can say that sides are equal. If we prove the similar, it is only able to say that sides are in the proportion, but angle will be equal. Here we are going to consider in the sides, that's why we are proving it as a congruent. So therefore which side we have to prove this equal? PB and ST. Yes, PB and ST. So PB is equal to ST by what? By corresponding parts of congruency triangle. So therefore what is the AB? AB is a AP plus BB. Here AS plus ST, right? So here AP plus PB, AP is equal to AS and PB is equal to ST, right? So just adding AP plus PB. So AP, just writing AP plus BB. AP is, we know that, is equal to AS, since by that theorem 10.2, and PB is equal to ST. PB is equal to ST. This is by above from this side, right? So AP plus PB is a AB. So AB is equal to AS plus ST is the AT. So this we have proved, right? If you want, you can write here AP is equal to AS by theorem 10.2. So it is also, we can say, adding the LHS and adding the RHS. So first we have proven that AB is equal to AD. So similarly we can prove for others also, right? So we no need to prove, just we can mention the word by similarly. This side we can say DC will be equal to BC. DC will be equal to BC, and if we say one more side, then it's enough. AB is equal to DC. This is by parallelogram itself. Normally by parallelogram itself we can say that AB is equal to DC, since opposite sides are equal. So now we just compare AB is equal to AD, where AD and here we say AB is equal to DC and DC is equal to AB, right? So AB is equal to, here is wrong, BD is a diagonal, right? We are talking about side BC. So this spot is a BC. So AB is equal to, we can say equal to BC also. AB is equal to AD and AB is equal to DC and DC is equal to BC. So AB is equal to BC is equal to, I am just writing in the order. CD is equal to AD. Therefore ABCD is a rhombus. So rhombus, just prove all sides are equal, enough. So here we go for the next problem. A triangle ABC is drawn to circumscribing a circle. So a triangle is a circumscribing. Circumscribing means outer and to the circle of a radius 4 centimeters. So the circle I have drawn this radius. This is a 4 centimeter, and such that the segment BD and DC into BC is divided by the point of contact D are of length 8 centimeter and 6 centimeter respectively. So BD is 8 centimeter and DC is 6 centimeter respectively. Find the side AB and AC. These two sides we have to find. So here we consider the triangle ABC with this as a radius. So this is like an point from the external point we have drawn the tangents. So let me join this point, this radius, and this point of contact. Let me call it as E and this as a F. So this is like a tangent. So BE will also be 8 centimeter and CD is equal to CF, and it is also be 6 centimeter, and this both tangent will be the same. Let me consider it as a X. So if we found this X, then we can find the side AB and AC, right? So let me, so what you have done, that BD is equal to BE is equal to 8 centimeter and CD is equal to EF is equal to 6 centimeter. CD is equal to CF is equal to 6 centimeter by theorem 10.2, right? So, and AF is equal to AE is equal to x centimeter, right? That's we have considered. So one thing we can learn in the triangle is area of the triangle, and there we have learned two formulas. One is with the perpendicular height and the base, and another is the Heron's formula. So whatever formulas we use, we will be getting a same area, right? So now I am going to use this Heron's formula to find the side, and that also will be represented in terms of x, and for the same triangle I am going to find with the height and the base, right? So first let me use the Heron's formula. So by Heron's formula, it says the area of triangle is equal to square root of s into s minus a into s minus b into s minus c, and here the ABC are the sides. S is the semi-perimeter, that is s is equal to a plus b plus c by 2. So that is the sides here. So this side is an 8 plus 6, and this side is 8 plus 6, and this side is a x plus 6x, right? So 8 plus 6 is a 14 plus this is x plus 8 plus this is a x plus 6 divided by 2, right? So it will be a 14 plus 8 plus 6, it will be a 28 plus x is a 2x divided by 2. If you divide the 2 by each term, we will be getting an 14 plus x centimeter, right? So by the area of triangle ABC is equal to square root of s into s minus a into s minus b into s minus c, right? So we know what is the s. S is a 14 plus x into s minus a. Let me consider a as an f, this 14. So x minus s is a x, so for x plus 14 minus this 14 into s is a 14 plus x. Just here I rewritten, don't be confused. And minus b is the x plus 8, that means minus x minus 8. So minus x minus 8 into here also s is a 14 plus x minus c is the x plus 6, that means minus x minus 6. So here plus 14 minus 14 is 0, plus x minus 6 0, plus x minus 6 is 0. So we will be getting it as a 14 plus x into is a hex, and here 14 minus 8 is a 6, and 14 minus 6 is 8, right? So 6 are 48x into 14 plus x square root of, right? This is the Heron's formulas. So let me keep it as equation 1. Let me find an area by the height, perpendicular height and the base. So let me join this C, O and OB. So I got a one triangle OCB with the perpendicular height 4 centimeter and the base. The same here also I can get, right? AOB. This is the perpendicular height 90 degree. We know that by the theorem 10.1, and this is the base. So we know this radius is 4 centimeter and this radius is also 4 centimeter. So if we add this small 3 triangles area, we will be getting a big triangle areas, right? Using that height and base. So area of triangle ABC is equal to, the first triangle is area of triangle OCB plus area of triangle BOA plus then the area of triangle, then this triangle COA. So area of triangle OCB. So OCB, this is the perpendicular height 4 centimeter and base is the 14. So half into 4 into 14, plus same here half into here, the always height is the 4, and what is the base here in this BOC? The height is the same 4, the base is x plus 8, x plus 8 plus the same here half into the height, that's the radius is same, into COV, here the same radius is height 4 and the base is x plus 6, right? So it will become a 2 times 2 times 2 times, so you'll be getting 2 into 14 is a 28 plus here 2 into x plus 8 plus here 2 into x plus 6. So let me expand this bracket, we will be getting it as a 28 plus 2x plus 16 plus 2x plus 12. So 2x plus 2x is a 4x plus 28 plus 16 plus 12, we will be getting it as a 2 3 4 48 50 56, right? 56. So 4x plus 56, the 4 is the common factor, so 4 into x plus 14 times the 56. So this centimeter square, equation 2. So we know that even we find the area with Heron's formula or area with an this altitude on the base, we will be getting the area same. But here both in the x, so let me equate the both 1 and 2. So we can eliminate the we can substitute simplify and we will be getting a x. So here it is a square root of 48x into 14 plus x, right, is equal to 4 into x plus 14. So let you take square to that side, it will become a square. So 48x into 14 plus x is equal to 4 square is 16 and here x plus 14 the whole square. So let me write that square because here and here it will be get cancelled, right? So other than the x, let me take that side because of 14 plus x and here is 14 plus x will be cancelled, that's why 16 into x plus 14 the whole square divided by 48 into x plus 14. So 1x plus 14 will be cancelled and 16 in 48 is what? 3 times. So here we will be getting a x is equal to x plus 14 by 3. So if you take 3 here, it will become a 3x. So 3x is equal to x plus 14. If you bring here, it will become subtraction. So it will become a 2x. 2x is equal to 14. Then x is equal to 7 centimeter, right? So x is equal to 7 centimeter. So we found x, but actually we need a AB and AC. So after finding the x as a 7 centimeter, what will be the AB and AC? Let me write here. So AB is equal to x plus 8. That is x we have found it as a 7 here, right? 7 plus 8 which is equal to 15 centimeter. So next one is AC. So AC is equal to x plus 6. So x is 7, 7 plus 6 is equal to 13 centimeter. That's clear. So here we are using Heron's formulas and the normal altitude and the base formula of area of triangle we compared and we have found the value for x. So here we go for the next problem. Prove that opposite sides of a quadrilateral circumscribing a circle subtends supplementary angle at the center of the circle. So first we have to draw the quadrilateral circumscribe. So here is the quadrilateral circumscribing a circle, suspending the supplementary angle at center of the circle. So from the center of the circle, let me join all the vertices of the quadrilateral. And since it's a quadrilateral, we cannot say about the diagonals, right? So 4 different ways I was joined. So it's O, right? Let me name the quadrilateral as A, B, C, D, and this as a O. So now we have to prove this opposite sides. So if we add these two sides, it should be supplementary, opposite sides taken. Otherwise, if these two sides is supplementary. If we talk about any one side, then automatically other sides will be supplementary. And we cannot talk about this angle directly, since we know up to this point is a tangent, right? So let me mark as usual about the radius, four side, and we can see that in the center there will be a 4 angle. So let me name that angle this as a 1, angle 2, angle 3, angle 4, angle 5, 6, 7, 8, totally 8 angle. So either 2 plus 3 plus 4, 7 plus 6 is equal to 180, or 8 plus 1 plus 5 plus 4 is equal to 180. We have to prove. So what we have done this, we have drawn a quadrilateral circumscribing that AB, BC, CD, AD touch the circle at P, Q, R and S. After that we joined OA, OB, OC, OD. OA, OB, OC and OD, and also we joined the point of contact. Let me name it as an P, Q, S. And we have joined OP, OQ, OP, OQ, OR and OS, right? So we know that we already proved that these two triangles are similar, right? This is a common and these two are radius, these are the same. When we compare, we can say that in triangle AO, OAP and OSA, these two triangles I'm comparing, we can say that these are the common. OA is equal to OA common. So why we are saying is we are going to prove these two angles are equal. So like that we can prove it. In theorem we can prove already this is bisect, even though we can prove here OA is equal to the common OP and OS. It's a radius and AP and AS. I hope you remember that we have proved in one of the problem. This is theorem 10.0, right? So therefore triangle OEP is similar to the triangle OA, same the OA, yes, right? So then by corresponding parts of similar triangle we can say that this angle 1 and 2 will be equal, right? Angle 1 is equal to angle 2. By the way, here similarly we can say that angle 3 and 4 will be equal, right? So angle 4 is equal to angle 3. By the way, the 5 and 6 is also equal, we can prove that, and 7 and 8 is also equal, right? So what is the central angle? Its total angle will be 360, right? One complete revolution. So angle 1 plus angle 2 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degree. So which 4 angles we need, we will keep as it is, and the rest we will be changing. So let me keep 2, 3, 7, 6. 2, 3, 7 and 6, right? That will making opposite angles, right? 2, 3 is opposite to 7, 6. So that's what we have to show, that prove that's a supplementary, right? Suspended are supplementary. This is the suspended, this is the suspended, and this is the suspended. Clear? So 1 we can rewrite as a 2, we already done. So angle 2 plus angle 2 plus 3 we need as it is, plus 4 we can write as an angle 3, plus 5 we can write as an angle 6, plus angle 6 plus angle 7 plus angle 8 we can rewrite as an angle 7. So it's equal to 360 degrees. So you can see two angles are 2 angle 3s are 2 angle 6 and 2 angle 7. So 2 into angle 2 plus 2 into angle 3 plus 2 into angle 6 plus 2 into angle 7 is equal to 360 degree. That is 2 times angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 360. So if we take 2 here, it will become division. So angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 180 degree, right? Since the 2 is divided. So angle 2 plus 3 is AOB. Angle AOB plus what is 7? 6 plus 7. 6 plus 7, this full angle COD. So angle COD is equal to 180 degree. Hence these both are opposite suspending angle, right? So hence we have proved. Hence proved. Clear, children? Already we proved this in the problem. You can write even that that we will be saying the line which bisects that POS from the external point. Otherwise you can prove this and you can proceed. Clear? Thank you.